Good afternoon, everyone. Welcome back to my channel. My name is Jonathan Klepaski. I'm a meteorologist. I've been forecasting the weather for over 13 years. Today's particular video, we're going to be discussing how to read a sounding. So what is a sounding? A sounding is where a weather balloon is launched with the National Weather Service at specific sites at specific time periods of the day. They are launched at 12Z and 0Z. And what I mean by 12 and 0Z, it is a universal time frame that where the entire planet can be on the same time um, scale. So 12Z in Oklahoma, which is what you're seeing right here, is approximately 0700 in the morning. These flights are launched about 2 hours before these particular soundings are released to the public. So it's actually around 5 o'clock in the morning where this particular one's taken. Now, what you're seeing right here is the red line is your temperature, while the green line is your dew point. That when they're closer together, these particular two lines is where you have more saturation, which is what you're seeing right here near the surface. And when you meet up like this is what we call an LCL, right about in this area. This is where the cloud bases, if they do form, will likely occur. And then as the atmosphere warms up right here, this is what we call an inversion. There's three different specific types of inversions. You have radiation, you have a frontal, and you even have a subsidence inversion. This is a clear radiation inversion because the atmosphere is quite cool near the surface. However, the atmosphere is really warmed up in the low levels. And as you can see here, the further apart they are, the more drier it is. But I want you to keep an eye on this feature right here because this is really important. How does a radiation inversion or versions break? Well, that's quite simple. There's a couple of events that can take place. You need either intense surface heating, upper level cooling, or some kind of significant lift to break through that barrier. Because this barrier, it's like a bottle cap on a soda bottle when it's shaken. It prevents anything from erupting through. Now, what you're also looking right here off to the right is a photograph. This photograph is pretty much this entire wind profile you're seeing right here, where the winds vary over specific periods of the atmosphere at certain magnitudes and speed. There's other variables here that you need to keep an eye on is the amount of CAPE and LI. CAPE is pretty much the amount of energy a thunderstorm is capable of producing once if any cells breaks through this barrier. LI, or lifted index, is measuring how much lift is occurring. And basically, the lower the number is, the more lift you have. And as you can see here, this particular sounding showing anything from between -9 to -15. So that is quite a bit of strong lift if that's occurring on this particular day. Something you're also seeing is this SRH. This is your storm relative helicity and is measured from the surface to 1 and the surface to 3 kilometers. Now, for those of you who do not know, you convert a kilometer by every 1,000 meters, and each meter is about 3 feet. So this is about surface to 3,000 feet in the atmosphere, and this one's about 9,000 feet in the atmosphere. And you can see it has some strong values of 300. This is quite common for your most destructive days of tornadoes. It's been well known that specific values are correlated to certain types of tornadoes, but there's a little bit more to it. Obviously, you can see here too, near the surface, there's quite a bit of wind shear, 25 to 27 knots. Something that's really useful is seeing the 1 6-kilometer wind barbs, because when they're more spread apart like this means there's more varying in the atmosphere, which is exactly what you want on a tornadic day. Something also you need to keep on is your steep lapse rates. When you have lapse rates like these, this is actually a good indication of a potential severe weather day because it shows how fast the temperature is cooling per kilometer. Now, what causes this inversion to break? Like I mentioned earlier, you need surface heating, upper level cooling, or intense lift. Now we're going to go to 5 hours later, give or take. And as you can see here, the inversion hasn't broken enough to allow any cells that's developed towards near the surface to punch through and encounter this amount of energy. Now, even though the relative humidity has dipped down a little bit, it's still quite volatile for tornadoes to develop, especially since the winds near the surface and the upper level winds are more veered apart. And like I mentioned earlier, the Mount Cape plays such a huge role when it comes to tornado genesis that you can tell is going from what we saw earlier of 1900 to as high as almost 5,000 over central Oklahoma. Clear evident that the diurnal pattern is starting to shift towards daytime as it progressed throughout the day. The light is much stronger, where we're seeing minus 13s now. It even shows quite a bit. The sea lapse rates have dipped down a little bit more, but it's still a pretty bad day for what happened. Now, I hope everybody enjoys this video. I'll be welcome to comments and other things you want to ask, and any other suggestions you want me to talk about weather. I appreciate your time. Have a good day.